our mentor and trainer's development program in AI, Artificial Intelligence. Based on author and researcher, Pradeep K. Suri. Based on the author's experience, the first step is we must train DNN, deep neural networks, using Python libraries for predictions, and then, second step, we must test DNN, deep neural networks, for the right forecast using the Python libraries. Now we are satisfied with the forecast result. Now we will provide unseen data for the predictions from our AI model for the predictions. Before all this data, source and cleaning of data is important. Pradeep K. Suri. Author and researcher. Now team emphasized the importance of data sourcing and cleaning, which is indeed a crucial step in the machine learning and deep learning process. Here's a more detailed breakdown. 1. Data sourcing. In the initial step, you need to collect the relevant data for your prediction task. Data can come from various sources, such as databases, APIs, files, or sensors, depending on the problem you are trying to solve. Ensuring that you have access to high-quality and representative data is a critical part of the process. 2. Data cleaning and pre-processing. Data can be messy and contain errors, missing values, outliers, and inconsistencies. Data cleaning involves tasks like handling missing data, removing duplicates, and addressing outliers. Pre-processing includes tasks like feature scaling, normalization, and encoding categorical variables to prepare the data for training and testing. 3. DNN model development. Once the data is cleaned and prepared, you can proceed with developing a deep neural network, DNN, model using Python libraries like TensorFlow or PyTorch. This involves defining the model architecture, loss function, and optimization method. 4. Training the DNN. The next step is to train your DNN model on the cleaned and pre-processed data. During training, the model learns from the data by adjusting its weights and biases. The goal is to minimize the chosen loss function, which measures the difference between the model's predictions and the actual target values. 5. Testing and evaluation. After training, you should evaluate the model's performance using a separate test dataset that it has never seen before. This step helps you assess how well the model generalizes to new, unseen data. It's crucial to use metrics and techniques to validate the model's effectiveness, such as accuracy, precision, recall, or mean squared error. 6. Deployment and prediction. If you are satisfied with the model's performance on the testing data, you can deploy it for making predictions on new, unseen data. This is often done in a production environment where the model can provide real-time or batch predictions. Your emphasis on data quality and preparation is well placed, as the quality of your data significantly impacts the success of your deep learning model. If your data is noisy, incomplete, or biased, it can lead to poor model performance. Therefore, thorough data sourcing and cleaning are essential steps in the machine learning and deep learning process. My next step will be to keep a mature AI engine in the AI Engine library for similar problem or concept training for the team. It sounds like you're planning to create a mature AI engine or model that can be used as a reference or training tool for your team to understand and work with specific problem domains or concepts. Here are some steps you can consider for this initiative. 1. Model documentation. Create detailed documentation for your AI engine. This documentation should include information about the model architecture, hyperparameters, data sources, data pre-processing steps, and the model training process. It should also provide insights into the problem domain the AI engine addresses. 2. Code repository. Store the code and scripts used to develop and train the AI engine in a version-controlled repository, example Git. Ensure that the code is well organized, well documented, and easy to understand for your team. 3. Model sharing. Share the trained model and code with your team through a shared repository or collaboration platform. This allows your team to access the AI engine for further exploration and learning. 4. Training sessions. Organize training sessions or workshops to help your team understand how to use the AI engine effectively. This can include hands-on sessions where your team members work with the model, fine-tune it for specific tasks, and interpret its results. 5. Use cases. Demonstrate real-world use cases for the AI engine within your specific problem domain or concept. Show how it can be applied to solve practical problems and provide value to the organization. 6. Monitoring and maintenance. Explain the importance of monitoring and maintaining the AI engine. Models can become outdated as data distributions change or as new data becomes available. Your team should understand how to keep the model up to date and accurate. 7. Collaboration. Encourage collaboration within your team. Share insights, best practices, and experiences in working with the AI engine. Promote a collaborative environment for learning and improving AI capabilities. 8. Feedback loop. Establish a feedback loop for continuous improvement. Encourage your team to provide feedback on the AI engine's performance and documentation. Use this feedback to make monthly updates and refinements. By creating a mature AI engine and providing your team with the resources and knowledge to work with it effectively, you can empower your team to better understand and apply AI in the context of specific problem domains or concepts. This can lead to improved decision-making, innovation, and problem-solving within your organization. The above concept will reduce the cost of expensive training and be bug-free. In my opinion, this is a bug-free fast development methodology. Your approach of creating a mature AI engine and providing it to your team for training and development is a strategy that can offer several advantages, including cost reduction and potentially reducing the risk of bugs. Here are some key benefits. 1. Cost reduction. By creating a well-documented and mature AI engine, you can reduce the cost and time associated with training new models from scratch. Your team can leverage the existing model and its documentation to expedite the development of AI solutions for specific problem domains. 2. Bug prevention. A mature AI engine with proper documentation can help prevent common errors and bugs that may arise during model development. Your team can follow established best practices and guidelines, reducing the risk of introducing coding errors. 3. Faster development. Having a pre-trained AI engine as a starting point can significantly accelerate the development process. Your team can focus on fine-tuning the model for specific tasks, rather than building a model from the ground up. 4. Knowledge transfer. Your team can learn from the AI engine and its documentation, gaining valuable insights into how AI models work and how they can be applied to solve real-world problems. This knowledge transfer can improve the team's overall AI capabilities. 5. Consistency. Using a mature AI engine ensures consistency in model performance and results. This consistency can be crucial in applications where reliability is essential. 6. Collaboration. Providing a common AI engine to your team promotes collaboration and knowledge sharing, as team members can work together on a shared foundation, share experiences, and collectively improve AI solutions. However, it's important to keep in mind that even with a mature AI engine, there may still be specific challenges and variations in different projects or problem domains. The AI engine may need some level of adaptation or fine-tuning to address the nuances of a particular use case. Also, monitoring for potential issues and model updates is still necessary to ensure the long-term effectiveness of the AI solutions. In summary, your approach can be a valuable strategy for faster, more cost-effective, and potentially bug-free AI development. It provides a solid foundation for your team to build upon while reducing redundancy and promoting consistency in AI projects. Of course, we have to develop new AI engines as per the new requirement, but concept clarity will be there. We will use an AI engine with version control. For all the above, we will use Jupyter Notebook. Using version control, like Git, for your AI engine and development processes is a good practice to maintain a clear and organized history of changes and facilitate collaboration within your team. Jupyter Notebooks are also a valuable tool for interactive data analysis, model development, and documentation. Here are some points to consider. 1. Version control. With version control, you can track changes to your AI engine's code, documentation, and data pre-processing steps over time. This allows you to easily roll back to previous versions if issues arise and maintain a history of your work. 2. Collaboration. Version control platforms, such as Git, enable collaboration among team members. Multiple team members can work on the AI engine simultaneously, contribute changes, and resolve conflicts through a structured workflow. 3. Jupyter Notebooks. Jupyter Notebooks are a popular choice for data science and AI development because they allow you to mix code, documentation, and visualizations in an interactive environment. They are well suited for documenting and sharing AI workflows. For reproducibility, Jupyter Notebooks help ensure the reproducibility of your work. You can include code, data, and explanations within a single document, making it easier to share and rerun experiments in the future. 5. Concept clarity. By using Jupyter Notebooks, you can provide clear explanations, visualizations, and insights into the AI engine's inner workings and the concepts behind it. This is valuable for knowledge transfer and training your team. 6. Flexibility. Jupyter Notebooks support notebooks programming languages, making them versatile for various AI-related tasks, such as data pre-processing, model training, and evaluation. 7. Documentation. You can use Jupyter Notebooks not only for code but also for documenting your AI engine's architecture, data sources, pre-processing steps, and other important information. This makes it easier for your team to understand and work with the AI engine. 8. New AI engines. While your team can use existing AI engines as a foundation, they can also develop new AI engines as needed to address specific requirements and use cases. Version control ensures that new AI engines can be seamlessly integrated into your workflow. 9. Training. Jupyter Notebooks can be used to create educational materials and tutorials to train the Notebooks team on AI concepts, best practices, and how to work with the AI engines. By combining version control, Jupyter Notebooks, and a structured development workflow, you can promote clarity, collaboration, and efficiency in your AI development process. This approach can help your team effectively build and adapt AI engines to meet new requirements while maintaining a strong conceptual foundation. Creating a comprehensive Python program for the entire concept you described earlier would be a substantial task, involving multiple components, including data sourcing, data cleaning, model development, version control, and Jupyter Notebooks. It would be beyond the scope of a single program and might require multiple scripts, notebooks, and project organization. However, I can provide you with a high-level outline of how you can structure such a project. You can then create Python scripts and Jupyter Notebooks for each component. Here's an overview of the key components. 1. Data sourcing and cleaning. Python scripts to source data from various locations, example databases, APIs, files. Data cleaning and pre-processing scripts to handle missing data, outliers, and data transformations. 2. Model development. Python scripts for defining, training, and evaluating the AI model. This might include TensorFlow or PyTorch code. Hyperparameter tuning and model architecture selection scripts. 3. Version control. Initialize a Git repository for your project to track changes over time. Use Git to manage different versions of your code, data, and documentation. 4. Jupyter Notebooks. Create Jupyter Notebooks for documenting your AI engine, including explanations, visualizations, and code snippets. Use Jupyter Notebooks for interactive data exploration, model experimentation, and documentation. 5. Collaboration and knowledge sharing. Share your project with team members using platforms like GitHub or GitLab to facilitate collaboration. Conduct training sessions or workshops using Jupyter Notebooks to educate your team. Here's a simplified example of how you might structure your project. In this structure, you can use Python scripts for data handling and model development, Jupyter Notebooks for documentation and interactive analysis, and Git for version control. Remember that creating such a project requires careful planning, clear documentation, and the development of Python scripts and Jupyter Notebooks tailored to your specific use case. Each component can be a substantial project on its own. Thank you.